Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope you all are fine. I am Amna Sadiq, working as subject specialist in mathematics at Divisional Public School and College Sahiwal. Today we are going to discuss about the equations that are reducible to quadratic form. This is exercise 1.3 and the related questions are 10 to 16. Before starting our today's discussion, let's recall some basic concepts from the previous lectures. Quadratic equation is an equation consisting of the polynomial of degree 2 with single variable. The standard form or the general form of quadratic equation is ax square plus bx plus c equal to 0. In this equation, a should not be equal to 0 and a, b and c are real numbers. If a is equal to 0 in the standard form of quadratic equation, then it reduces to the linear equation bx plus c equal to 0. And if b is equal to 0 in the standard form of quadratic equation, then it is called a pure quadratic equation with the terms ax square plus c equal to 0. We use three methods to find the solution set of quadratic equation. The first one is by factorization method, second by completing square, and the third is by quadratic formula. We have already discussed in the previous lecture about the two equations that can be reduced into quadratic equation. The first one was the equation of the type ax raised to power 4 plus bx square plus c equal to 0. In this equation, if x square is equal to y, then the quadratic equation in the standard form can be written as ay square plus by plus c equal to 0. The second equation is of the type a multiplying with a polynomial plus b dividing by a polynomial equal to c. In this equation, if we replace the polynomial by y, we get a new equation ay plus b over y equal to c. And if we solve it and write it in the standard quadratic equation form, we get ay square plus cy plus b equal to 0. And today we are going to discuss about type 3, 4 and 5. The next type we are going to discuss today is called the reciprocal equation. In this equation, a is multiplying with x square plus 1 over x square plus b is multiplying with x plus 1 over x plus c equal to 0. This equation can also be written as ax raised to power 4 plus bx cube plus cx square plus bx plus a equal to 0. An equation is said to be a reciprocal equation if it remains unchanged when x is replaced by 1 over x. If we replace x by 1 over x in the given equation, ax raised to power 4 plus bx cube plus cx square plus bx plus a equal to 0, we have a multiplying with the reciprocal of x raised to power 4, b multiplying with the reciprocal of x raised to power 3, c multiplying with the reciprocal of x square, plus b multiplying with the reciprocal of x plus a equal to 0, which when simplified becomes a plus bx plus cx square plus bx cube plus ax raised to power 4 equal to 0, which is same as the previous equation. So this is called the reciprocal equation. Let's explain this with the help of a question. Solve the following equation: x raised to the power 4 minus 2x cubed minus 2x squared plus 2x plus 1 equal to 0. We can easily observe that this is the reciprocal equation. The first term is x raised to the power 4, second is minus 2x cubed, third is minus 2x squared plus 2x plus 1 equal to 0. So we are using the concept of reciprocal equation. We divide each term by x squared and get x raised to the power 4 divided by x squared minus 2 times x raised to the power 3 over x raised to the power 2 minus 2 times x squared over x squared plus 2 times x over x squared plus 1 over x raised to the power 2 equal to 0. After simplification, we get x raised to the power 2 minus 2x minus 2 plus 2 over x plus 1 over x raised to the power 2 equal to 0. We rearrange this equation as the terms with square x raised to the power 2 plus 1 over x raised to the power 2 minus 2x plus 2 over x minus constant term equal to 0, which can also be written as x square plus 1 over x square minus 2 times x minus 1 over x minus 2 equal to 0. Now we put x minus 1 over x equal to y to get x square plus 1 over x square. Squaring both sides, we get x minus 1 over x the whole square is equal to y square. As we know that this can be expanded as x square plus 1 over x square minus 2 equal to y square. Taking the constant term from the left hand side to the right hand side, we get x square plus 1 over x square equal to y square plus 2. So, x square plus 1 over x square in equation 1 can be replaced by y square plus 2. Putting these values in equation 1, we get y square plus 2 minus 2y minus 2 equal to 0. This plus 2 and minus 2 cancel each other and we get a new equation y square minus 2y equal to 0. Taking y as a common, we have y times y minus 2 equal to 0. From here we get two roots, either y is equal to 0 or y minus 2 is equal to 0. So we have y is equal to 2. Putting these two values of y is equal to 0 and y is equal to 2. In equation 2 we get x minus 1 over x is equal to 0 or x minus 1 over x is equal to 2. Solving these two equations, we get x square minus 1 equal to 0 or x square minus 1 equal to 2x. X square is equal to minus 1 and x square minus 2x minus 1 equal to 0. X square equal to 1 can be solved by taking square root on both sides and we get x is equal to plus minus 1 and x square minus 2x minus 1 is equal to 0 cannot be factorized, so we apply the quadratic formula. That is, x is equal to minus b plus minus square root of b square minus 4ac over 2a. Here b is equal to minus 2, so we put minus b equal to minus times minus 2 plus minus minus 2 square minus 4, the value of A is 1 and the value of C is -1. So we put -4 times 1 multiplied by -1 over 2 times 1. Simplifying this quadratic formula, we get 2 plus minus square root of 4 plus 4 over 2, which can be written as 2 plus minus square root of 8 over 2. Writing the square root of 8 as 2 square root of 2, we get 2 plus minus 2 under root 2 over 2. Taking 2 as a common in the numerator, we get 2 times 1 plus minus square root of 2 over 2. Cancelling 2 with the 2, after cancellation we get 1 plus minus square root of 2. So we get 4 values of x plus minus 1 and 1 plus minus square root of 2. So the solution set is plus minus 1 and 1 plus minus square root of 2. The fourth type is called the exponential equations. In exponential equations, variable occurs in the exponents, and this process can be explained by using a question. So we have to solve the following equation. 4 times 2 raised to power 2x plus 1 minus 9 times 2 raised to power x plus 1 equal to 0. This cannot be read as 4.2. It is read as 4 multiplied by 2. This dot means multiplication here, as two different types of numbers are multiplying. 2 raised to power 2x plus 1 is an exponential number multiplying with 4. Similarly, 2 raised to power x is an exponential number multiplying with 9. So first of all, we break 2 raised to power 2x plus 1 as 2 raised to power 2x multiplying with 2. This 2 raised to power 2x can also be written as 2 raised to power x the whole power 2. This is called the power law. This 4 multiplied with 2 becomes 8. Let this 2 raised to power x equal to y, and replacing it in equation 1, we get 8y square minus 9y plus 1 equal to 0. We can solve this equation by any of the three methods: by factorization, by completing square, or by quadratic formula. I am solving here by using factorization method. For the factorization method, we multiply the coefficient of y square with the constant, that is 8 multiplied by 1, which is equal to 8. Now we find two factors of 8 that when added or subtracted becomes 9. We can say 8 plus 1 is 9, so we replace 9 by 8 plus 1. When solving this, we get minus 8y minus y plus 1. Taking 8y as common, y minus 1 minus y minus 1 equal to 0. When we have nothing in common, we say it's 1. Y minus 1 is the common factor, and the remaining terms are 8y minus 1, which is equal to 0. So, we can say that either y minus 1 is equal to 0 or 8y minus 1 is equal to 0. Solving them for the values of y, we get y is either equal to 1 or y equal to 1 by 8. Putting this in equation 2, we get 2 raised to power x is equal to 1 or 2 raised to power x is equal to 8. This 1 can be written as 2 raised to power 0, and this 1 over 8 can be written as 1 over 2 raised to power 3, or 1 over 2 the whole power 3, or 2 raised to power minus 3. So solving them for the value of x, we get either x is equal to 0 or x is equal to minus 3. So the solution set is 0 and minus 3 enclosed in the braces. The next type is the equation of the form x plus a, x plus b, x plus c, x plus d equal to k, and in this equation a plus b is equal to c plus d. The process of solving these types of equation is also explained by using a question. We have an equation x plus 1 multiplying with x plus 3 multiplying with x minus 5 multiplying with x minus 7 equal to 192. Before starting this question, if we add 1 plus 3 we get 4, and if we add minus 5 with minus 7 we get minus 12. So we need to arrange this equation first. Rearranging the equation we get x plus 1, x minus 5, x plus 3, x minus 7 minus 192 equal to 0. Now 1 when added with minus 5 we get minus 4, and plus 3 when added with minus 7 we get minus 4. So we get two same factors. Multiplying them respectively we get x raised to the power 4 minus 4x minus 5 and x raised to the power 2 minus 4x minus 21 minus 192 is equal to 0. This x square minus 4x is common, so we replace it by y. And the equation 1 becomes y minus 5 multiplying with y minus 21 minus 192 equal to 0. Again multiplying them we get y raised to the power 2 minus 26y plus 105 minus 192. Solving them we get y square minus 26y minus 87 equal to 0. We get two factors of 87 that when subtracted becomes 26. 29 minus 3 when subtracted we get 26, and when they are multiplied we get 87. So we solve them by using factorization method and get y minus 29 multiplying by y plus 3 equal to 0. Either y minus 29 is equal to 0 or y plus 3 is equal to 0. When solving them for the values of y, we get y is equal to 29 or y is equal to minus 3. Putting these two values of y in equation 2, we get x square minus 4x is equal to 29 or x square minus 4x is equal to minus 3. Rearranging them, we get x square minus 4x minus 29 equal to 0 or x square minus 4x plus 3 equal to 0. Now solving these two equations, the first one cannot be solved by factorization method, so we can use quadratic formula. The second one can be solved by using factorization method, so we can factorize it. Putting the values of a, b and c in the quadratic formula, we get x is equal to 4 plus minus square root of 16 plus 116 over 2. And similarly, this equation can be written as x square minus 3x minus x plus 3 equal to 0. 16 plus 116 can be written as 132, and these two terms have x in common, so we can write it as x times x minus 3 minus 1 is common between x and 3, so we get x minus 3 equal to 0. 132 can be written as 2 square root of 33, and this can be written as x minus 3 and x minus 1. X minus 3 is the common factor and the remaining terms are x minus 1. Taking 2 as a common factor in the numerator, we get x is equal to 2 times 2 plus minus square root of 33 over 2, or x minus 3 is equal to 0, or x minus 1 is equal to 0. After cancellation, we get x is equal to 2 plus minus square root of 33, and solving these two values for x, we get x is equal to 3 or x is equal to 1. Writing them in the solution set, we get 1, 3 and 2 plus minus square root of 33 enclosed in the brackets. Let's recapitulate our today's lecture. We have discussed that there are many equations that can be reduced into the standard form of quadratic equation and thus can be simplified by using three methods: by factorization method, by completing square method, and by quadratic formula. Among them, the first type of the equation is ax raised to power 4 plus bx square plus c equal to 0. In this equation, we replace x square by y and get a standard quadratic equation as ay square plus by plus c equal to 0. The second type of the equation is a polynomial with the variable x plus b divided by the polynomial with the variable x equal to c. In this equation, we replace p of x, means the polynomial, with the variable x equal to y and get a new quadratic equation in the standard form with the variable y. The third type is the reciprocal equation. In the reciprocal equation, we replace x by 1 over x in the given equation. The next is the exponential equations. In exponential equation, variables occur in the exponent. They can be written in the form a m raised to power exponent, which contains the variable x, plus b multiplied by m raised to power exponent with the variable x, plus c equal to 0. This exponent x can be written in any polynomial form. Here a, b, c and m are real numbers. The next type of the equation is x plus a, x plus b, x plus c, x plus d is equal to k. In this equation, a plus b should equal to c plus d. You should remember some important points. Quadratic equation in the standard form can be written as ax raised to power 2 plus bx plus c equal to 0. Here are some examples of the quadratic equation written in the standard form. Here are some examples of the quadratic equation that lacks the linear term or the linear coefficient b is equal to 0. That is, we have pure quadratic equations. Here are some examples that are representing pure quadratic equations. The next is the example of quadratic equations that are lacking the constant term or the c, like x square minus 7x equal to 0. We can say that here c is equal to 0. Quadratic equations can also be written in factored form. X plus 2 multiplied by x minus 3 is equal to 0. When we compute them or simplify them, we get x square minus x minus 6 equal to 0. Quadratic equations can also be written in some other forms, like x times x minus 2 equal to 4. When we multiply them and simplify it, we get x square minus 2x minus 4 equal to 0. You can also observe the other examples. Now it's time for your home task. Please complete the remaining questions of exercise 1.3 and also solve the related examples 3, 4 and 5. Dear students, that's all from our today's lecture. I hope you understand our today's topic. Thank you very much.